Good morning. Uh, Today we are going to discuss how to determine the center of gravity for different sort of objects. So here I am taking three perfect examples that we commonly encounter in our day-to-day scenario. As a biomechanist or as a physiotherapy student, it will be of great help if you can determine the center of gravity for an object. First, I am just taking the example of a symmetrical object. Suppose I am taking the example of a symmetrical object. It's like this. Consider this as a sphere. For a symmetrical object, the greater amount of weight or the center of gravity lies in the exact center. Okay, for a symmetrical object, the center of gravity is at the exact center. This is the first example. For second example, I am considering the case of a non-symmetrical object. You can consider this as a baseball bat. So in case of a non-symmetrical object, the greater amount of weight is concentrated at the most heavier end. So in this case, where the most heavier end is located, the center of gravity will be exactly at that point. So in this case, this becomes the center of gravity. So now a question comes for an asymmetrical object. If an asymmetrical object comes, how you will locate the center of gravity? The only thing is the maximum amount of lines that intersect at a particular point, that becomes the center of gravity for a non-symmetrical object. So this is for a perfectly spherical object, it's the exact center. For a or a not for an asymmetrical object, for a object that is heavier at one side or a non-uniform object, the center of gravity is located more nearer to the heavier side. For an asymmetrical object, whenever you join all the coordinates of the system, where exact center is there, that becomes the center of gravity for an asymmetrical object. So thank you all. That's for now.